Hello everyone, I'm Natasha Crampton. I'm Microsoft's Chief Responsible AI Officer, and I have the privilege of working with world-class researchers such as Meredith Ringel Morris, who leads the Ability team in Microsoft's Research Division. Today, Meredith and I are going to delve into a couple of topics. First, how Microsoft approaches responsible AI, and then Meredith is going to cover some important research directions related to disability and AI. I'm going to begin with a story about Theo, a 13-year-old boy who's blind. In the image that's been presented, Theo is seated at a table. He's wearing a headband that houses cameras, a depth sensor, and speakers. It forms a ring around his sandy brown hair. Using the device, Theo swivels his head to the left and right until the camera in the front of his headband points at a person who is on the far side of the kitchen counter. Theo hears a bump sound followed by the name Martin through the headband speakers. For Theo, this is a tool to recognise that Martin is in the space around him. And to use Theo's own words, "It is so exciting to be able to find out where the people are in my environment, not just who chooses to talk, but all of the people who are silent that you can see by their face, but I can't." What I'm describing is a research project out of our research lab in Cambridge, England. It's called Project Tokyo. What I love about Project Tokyo is that it helps us imagine new futures in a way that's a very compelling example of how to put ethics and responsible AI issues front and centre when you're building a system. I'm going to use it as an illustrative example today to help bring our approach to responsible AI to life. But before I do that, I'm going to answer a question that I'm pretty sure is on at least some of your minds, which is, why responsible AI? What makes AI different to other technology that has come before it? Satya Nadella puts it well when he says, AI isn't just another piece of technology. It could be one of the world's most fundamental pieces of technology that the human race has ever created. For the very first time, we're endowing computers with capabilities once reserved to people, like the ability to hear, to see, to understand. So we really think this could be as important as other technological advances, such as the printing press, electricity, or the internet. You know, it's the internet that's brought us all here together today, and it allows us to connect. But I think we all recognise that it's also the same technology that can allow hateful and divisive messages to spread. And so for that reason, we think it's really critical to apply the same kind of thought that we did to those other technological advances to the advance of AI. So we need to think critically and deeply, not just about what the technology can do, but what it should do. We really need to look at the future with a critical eye. So Microsoft's approach to AI is really centered on three key tenets. The first tenet is that we aim to build AI systems that augment human abilities. And Cecily Morrison, who leads the Project Tokyo team, I think captures this really well when she says that successful human AI partnerships don't make humans superhuman by making them, giving them completely new abilities. Instead, we should use AI to make humans super at being humans by extending the capabilities that they already have. Indeed, I think part of what makes AI so promising is the fact that computers really think differently to the way that we do. If you're anything like me, you're not very good at probabilistic reasoning, but AI technology does that incredibly well. Most of us can't remember everything, but computers never forget. Yet computers lack very human traits like empathy and judgment. So we really do have this fantastic opportunity as a society to marry the best of AI and its abilities with human abilities, and thereby commit ourselves to a human-centered approach to AI. The second tenet is that we aim to make AI available to everyone. There's no doubt that AI offers incredible opportunities to drive widespread economic and social progress, and I'm sure you've seen some of that come to light during the course of the Ability Summit program. And yet, to realise these opportunities, we really need to make AI available as broadly as possible. We need to empower everyone to create their own solutions. The third tenet is really what I'm going to focus on today, which is really about making sure that we are guided by a set of ethical principles. We believe that living up to ethical principles will be essential if we are going to be building AI systems that will be broadly accepted and trusted. So as a company, we've articulated these 6 core principles to guide our approach to developing and deploying AI systems. AI systems should be fair, reliable and safe, private and secure, and inclusive. And those 4 principles are supported by 2 foundational principles of transparency and accountability. As we've been working through these issues at Microsoft, these principles have really been critical to the way in which we go about things. So we've used them to guide engineering decisions about whether and how to develop certain services. And we've also used them to guide our approach to selling technology, sometimes even making the decision to not proceed with a particular deal because we determined that there would be a conflict with our principles. Yet we know from our own lives that principles alone don't give you the answers when you are trying to resolve, difficult ethical questions, and they don't always resolve. Individual principles can also be in tension with one another, and we need to recognise and develop a practice as to how we might resolve those tensions. So let me return to Theo for a moment and one of the use cases that he jointly developed with the Project Tokyo team, because I think this is a great illustration of the kinds of questions that we're actually asking in practice when we put these principles to work. So it might feel like a long time ago, it certainly does to me, but can you remember going to a coffee shop in the morning, observing the same people in the queue because you're there at roughly the same time, never having introduced yourself to one another, but you smile at them knowingly, aware of the fact that you're about to get your morning caffeine shot? Or have you been in a situation where you've passed through a village and you've passed by someone you've known your whole life, but who you've never met? This scenario is what we call a familiar stranger scenario, and it's a really interesting scenario to think through in the context of the Project Tokyo system that Theo helped to develop. The familiar stranger scenario requires that the system needs to recognise a person in the sense of knowing that it's the same person, not knowing the specific identity of that person without their consent, which gives rise to a bit of a dilemma, and that's that increasing the privacy of the familiar stranger could impact the ability for a user of the system to feel included. And so when we talk about these sorts of scenarios at Microsoft, we call this a value tension. And sometimes people think about value tensions as polarities, but we really prefer to think about them as a quadrant. So we try to ask ourselves, how can we thoughtfully innovate in a way that gives us more privacy and more inclusion? How can we create technology that forefronts inclusion, but is also considerate of the harms that could come from breaches of privacy? When we put these sorts of challenges to our teams at Microsoft, they come up with some really interesting ideas as a result. So sometimes they think about different interaction challenges and techniques to really try and drive better social interaction and understanding. So in the case of Theo, is there a way, for example, to communicate to a bystander that they're approaching the field of vision so that they're then in close contact for recognition? Because that would give them a choice as to whether they want to be recognised in that scenario or not. Or could we think about technical approaches like de-identifying personal information or using really finely tuned algorithms to resolve those tensions in a way that gives us more privacy and more inclusion? And then sometimes it's just about a different user experience. So we needed to recognise for Theo, for example, that children sit close together. And if your children are anything like mine, they seldom sit still. So Theo had the same experience in that he found it challenging to have the agent announcing several different friends' names in quick succession as the children congregated around him. So working through that kind of value tension is just one example of how we put our principles into practice at Microsoft. So what we're trying to do in the responsible AI space is really to take a leaf out of our playbooks for privacy, security, and of course, accessibility. So we always want to start with principles, but we quickly want to move into practices. And what we've learned about the responsible AI space is that moving from principles to practices is a process, and it involves trade-offs, translation, and experimentation. So the reason we need translation here is that we need to move from academic literature to concepts and even vocabulary, language that our engineers and salespeople understand. We've got to translate between domains. We've also got to make trade-offs because in the real world, constraints as we are engineering new products exists. And what's more, the real world is constrained. So we want to make sure that our customers and our partners understand those constraints as they're deploying our technologies. And sometimes we just have to experiment. We sometimes think a technique will uphold our principle, and it turns out that that's not necessarily the case. Now, beyond practices, we really think tooling is the next critical step. We really want to make it easy and efficient for our people to do the right thing. And one of the most exciting releases at Build, for me at least, was the release of some responsible AI tools that we've now integrated into Azure ML so that our customers and partners get the benefit of these new advances as well. So there was an intelligibility toolkit as well as a fairness offering, differential privacy, and a variety of other new tools that are now available to all of our customers. Finally, governance. For me, governance is fundamentally about making sure that we're living up to our values. We're doing what we say we're going to do. We put in place clear roles and responsibilities and checks and balances. But for me, if there's one key ingredient in upholding our responsible AI principles, it is unquestionably the people. The people who work across disciplines, bring users in as co-collaborators, and look for creative solutions where value tensions exist. The photo I'm showing is a case in point. Peter Boscher, who appears in the middle of the image wearing the Project Tokyo system, is an audio engineer who is blind. Peter worked with the Project Tokyo team early in the design process. On the left, we have Martin Grayson, who is a senior research software development engineer. And on the right, we have Cecily Morrison, who's a human-computer interaction researcher and the lead of the Project Tokyo research effort. That kind of multidisciplinary collaboration involving users of the system is exactly what we aim for. It really is a hallmark of our approach to responsible AI at Microsoft, that it's not we have an ecosystem. It's not just about a single person or a single organization working on these problems. We work across organizational boundaries. So the Office of Responsible AI that I lead combines with Ether, our cross-company advisory board, researchers, engineers, to really work through some of these hard questions together and try and bring a number of different perspectives to them. And for me personally, it's a real pleasure that I get to work with researchers and engineers and designers and ethicists on a day-to-day basis. I'm also convinced that that's the only way that we are going to succeed in our ambition to deliver AI systems that benefit everyone. We need to build AI technologies with and for people, recognizing the broad range of human needs and experiences that make this world such a wonderful place. So before handing over to Meredith, I'd like to highlight for you just a couple of resources that I hope you'll find helpful. First, I've included a link to our Responsible AI Resource Centre. That link is aka.ms Responsible AI Resources. There you'll find a range of guidelines, links to our tools. You'll find a research collection, you'll find podcasts, all collected there, and we'll add to it over time as we develop more and more practices that we want to share with everybody. And second, you'll find a link to a more detailed story about the Project Tokyo research effort that's been central to my talk today. That link is aka.ms/Project Tokyo story. It's a great read, and it's one that will make you feel like the Project Tokyo team is well on the way to achieving their goal of demonstrating how to build intelligent personal agents that extend the capabilities of all users. Over to you, Meredith.
Thank you so much, Natasha. My name is Meredith Ringel, and I lead the Ability team within Microsoft's Research Division. And I wanted to share an update on activities within Microsoft Research related to the topic of disability and AI. The Ability team conducts research aimed at developing innovative technologies that extend the capabilities of and enhance the quality of life for people with disabilities, whether that's long-term, temporary, or even situational disabilities. Our mission is to conduct foundational, user-oriented research to understand the technology-related challenges and needs of people with disabilities, and to invent novel, inclusive technologies that combine advances in human-centered computing and artificial intelligence. You can read more information about the Ability team's past and current research initiatives on our website at aka.ms/MSRAbility, which includes not only research articles, but also videos, blog posts, and podcasts from our team. For the past 2 years, the topic of AI fairness and disability has been one of our team's major research initiatives, and our research has helped inform Microsoft's policies regarding inclusive AI. First, we've developed a research roadmap for the academic community to help identify and remedy shortcomings of AI systems for people with disabilities. First, it's important to identify ways in which inclusion issues for people with disabilities might impact AI systems. Second, it's important to test inclusion hypotheses to understand the failure scenarios and the extent to which existing bias mitigation techniques work. Third, it's important to create benchmark datasets to support replication and inclusion and to handle the complex ethical issues that creating these datasets for vulnerable groups might involve. And finally, it's important to innovate new modeling, bias mitigation, and error measurement techniques in order to address any shortcomings of status quo methods with respect to people with disabilities. If you want to learn more in depth about this research roadmap, you can download our article at aka.ms/AIA11Y. In March last year, Microsoft sponsored and co-organized a workshop with the AI Now Institute at NYU to convene experts in the areas of AI, accessible technologies, and disability studies from across academia and industry for a 2-day meeting to discuss the important topic of disability, bias, and AI. The AI Now Institute published a white paper this winter that summarizes the key aspects of those conversations, helping ensure visibility of people with disabilities as a key constituency for technologists and policymakers to consider when designing, developing, and testing AI systems. You can access the white paper yourself at aka.ms/AI Now Report. We also helped organize and sponsor a workshop at last fall's ACM Assets Conference. ACM Assets is a leading conference on academic research in assistive technologies. This workshop was on the topic of AI fairness for people with disabilities, and again brought together experts from industry, government, and academia, including disability self-advocates, to discuss this topic. You can find the full workshop program, including details of all the papers and posters presented at the workshop, at aka.ms/assets2019 workshop. More recently, this January, Microsoft Research joined the Georgetown University Institute for Technology, Law, and Policy to convene a panel discussion on the topic of centering disability perspectives in algorithmic fairness, accountability, and transparency at the ACM FACT Conference, which is the leading conference on the topic of AI fairness, accountability, transparency, and ethics issues, in order to bring more visibility to this community for the need of inclusion of people with disabilities in discussions of AI fairness. The panel was chaired by Alexandra Reeve-Givens from Georgetown Law, and also the vice chair of the Christopher and Dana Reeve Foundation, and it included experts from industry and academia, including disability studies scholars and disability self-advocates. While the panel itself wasn't recorded, the slides that were presented by the panelists are available to you if you're interested at aka.ms/FATE slides. We're also starting a public conversation about the complex ethical issues that underlie AI systems that impact people with disabilities. These are challenging questions, and the correct solutions aren't always clear, but we feel it's important to be aware of and discuss these sensitive issues to help shape Microsoft's approach to this topic. Some of the challenges we've identified include inclusivity. For example, are people with disabilities represented in AI training data? Bias. Do AI systems amplify real-world biases against people with disabilities? Privacy. Is re-identification from anonymous data sets enhanced in its risk for people with disabilities? Error. How can we convey to end users the error that's inherent in AI systems, especially when users cannot verify the output of the system with their own senses? Expectation setting. What are realistic breakthrough timeframes for AI advances, and how can we communicate these to non-technical end users? Simulated data. Synthetic data is increasingly common in many AI training algorithms, but it's especially problematic with respect to simulating disability. How can we resolve these tensions in the AI community? And finally, social acceptability. How can we balance the needs of end users versus bystanders? This was an example that Natasha brought up when she discussed the trade-offs of inclusivity and privacy with the Project Tokyo system. I've written an article that discusses each of these 7 ethical challenges in more detail that you can download at aka.ms/AI4A ethics to learn more. As an example of investigating the challenge of inclusivity of data about and from people with disabilities in AI training datasets, Microsoft Research has partnered with the University of Texas at Austin to conduct research on making sure that automatically generated image descriptions meet the needs of people who are blind. In particular, most current vision-to-language algorithms are trained on images taken by people who are sighted, which differ in many ways from images taken by people who are blind or who have low vision. With a grant from Microsoft's AI for Accessibility program, UT Austin researchers have released a new dataset, VisWiz Captions, which is a dataset of images taken by blind photographers. And we're jointly hosting a workshop on June 14th as part of CVPR, which is the leading computer vision conference, where researchers will share the results of their new algorithm's attempt to learn to label these images based on this more realistic data from blind end users. This workshop will also feature talks and Q&A sessions with blind technology advocates such as Chancey Fleet, Sina Baram, and Cindy Bennett to help ensure that computer vision researchers have a user-centered perspective on this important problem. You can learn more about the workshop and the dataset at aka.ms/VIZWIZ CVPR 2020. We also have a number of ongoing projects in my team related to the topic of AI fairness and disability. For example, we recently conducted a study with 40 adults with physical disabilities such as limb differences or limited mobility, in which we collected information about this group's experience with various types of smart sensing devices in order to better understand what issues may need further examination for making these devices fair and inclusive to people with varied body types and mobility capabilities. We're also working with members of Microsoft's AI research team to develop guidelines and best practices for auditing or evaluating deployed AI systems for fairness with respect to people with disabilities. Finally, we're beginning an exploration of the extent to which older adults are represented in many commonly used AI training data sources. To stay up to date with our research results as they're released, you can always check back to our team's website, aka.ms/MSRability. And now that's the end of the formal part of the presentation, and Natasha and I would love to take any questions that you have about this topic.
There are a couple questions about this work. Natasha, what kind of impact have you seen in the use of Project Tokyo?
Thanks, Heather. I think the project team has really seen that there's a real opportunity for users of a Project Tokyo-like system to build the experience themselves and to do that in a way that doesn't overcrowd them. Users of the Project Tokyo system actually already have really sophisticated ways of using additional information that the system may be able to offer them and aiding understanding. So, for example, in the case of adults, just knowing that there was someone else, another person over in the same space was enough for that to lead to the initiation of a conversation. So it would lead them to go over to the person and start a conversation. And in the case of a child, the team has also seen that there can be really powerful changes to social interactions. So a child who might previously have talked with his head resting on the table, ignoring eye contact, uses a system like Project Tokyo and then comes to understand that looking at people actually makes them more engaged. And that learning comes about because to use the Project Tokyo system and the device to do its job, he has to actually look at someone in order to identify them. So that's a really powerful change in social interactions there. And I think it just reinforces that point earlier, which is that, you know, as Cecily Morrison would say, you can make humans super at being humans if you add on to the existing capabilities that they have.
And Meredith, how has Microsoft's research focus on AI and disability influenced the rest of the company?
So as Natasha mentioned, the company has been developing our own internal guidance for our engineering teams about responsible and inclusive AI. And a lot of the research that I discussed from my team actually directly informed making sure that guidelines around making AI inclusive for people with disabilities is a part of that document and a part of the training that's now given to Microsoft engineers as part of the Responsible AI program.
Well, thanks very much, everyone. It's been great to be able to engage with you today. This is a really important topic for us, and you know, we couldn't do it without people like Meredith giving us those really important insights, research-led insights, in how we can make sure that we're making available products and services that live up to our principles. So we look forward to engaging with you further on this topic. Thanks very much.
Thank you.